Hey guys, so today what I'm going to show you is how you can do math with emojis, no numbers required. So I'm going to only use 3 emojis because I want this example to be simple. So we're going to use happy, sad, and indifferent. Now we can't really use the operations we're accustomed to with numbers like addition, multiplication, subtraction, and division because we're not using numbers, we're using emojis. So instead we're going to create an operation. So let's just call that operation triangle, okay? So now that we have our operation triangle, let's see how they interact with one another. So I'm going to define it this way. Happy triangle happy is happy. Sad triangle sad is sad. Indifferent triangle indifferent is indifferent. Okay, but what when they interact with one another, what's going to happen? Well, I'll say that happy triangle sad is indifferent. Happy triangle indifferent is happy. And sad triangle indifferent is sad. What I'm also going to do is I'm going to say, well, if I flip these around, in other words, if I say sad indifferent is going to be the same as indifferent sad, or sad triangle indifferent is going to be same as indifferent triangle sad. Okay, so what I've created here is what's called a group, and what this group has is an operator. So a group is just a collection of things, and the operator in this case is a binary operator, meaning it works on 2 elements. And in fact, what I've done with this group is I've created not only an operator, but I've also identified what's referred to as an identity element and a inverse element. So what is an inverse? So to think about this, let's go back to addition. But let's go back to addition with numbers and, in fact, just the integers. So the integers are the counting numbers 0 and negative. So if we look at the operation of addition, we have an identity and it's 0. So if I get any element and add it to 0, I get that element back. And what is that inverse? Well, the inverse is when I have an element and I do an operation with some other element, the result is the identity. So for example, if I have 4, its inverse would be -4 because 4 plus -4 is 0. Okay. And if we go to other operations, we have the same result defined slightly different. So for example, if I have multiplication, well, with multiplication, if I expand it to all the numbers, the identity would be 1. Any number multiplied by 1 will give me that number. And the inverse will be, well, what we think of the inverse is putting that number in the denominator of a fraction. So the inverse of 4 would be 1/4 because 4 multiplied by 1/4 equals 1. Now, something that I said also that may seem obvious because you think in terms of addition and multiplication is that the order I do it in, it doesn't really matter. This property is called abelian, and not every group and operator has this property. So with multiplication and addition, it's obvious that it's abelian. But when you think about division or subtraction, 4 divided by 1 is not the same as 1 divided by 4, and 4 minus 1 is not the same as 1 minus 4. So what we've done here is we've introduced ourselves to a branch of mathematics which is called group theory, because mathematicians, numbers is just one set of tools that we use. But what we can do is we can study any objects and we can see how those objects interact with one another, and we can come up with different ways of defining that interaction. So what I have is a group, which I've defined as being the emojis, happy, sad, and indifferent, and I have an operator. And within this group, I have a inverse for each element. I have an identity, and then I have the property of it being abelian. And then also the group is closed, meaning that whatever 2 elements I operate on, the result will always be within the group. This isn't always the case, so think about it. If I look at the group of, going back to my integers, if I have the operation of division, it's not closed because 1 divided by 2 is not an integer. So this is something that's done in advanced mathematics and modern algebra. And if you don't take any advanced math classes, you'll probably never see this. In fact, the people who only usually see this are in fact math majors. But now you know some advanced math too. Thank you.